Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 29, 2025, about 2 days ago. This paper shows that a vision language model can teach itself through Who is the Spy style games made from arbitrary image pairs, lifting its win rate versus a fixed baseline from 50% to 71% using label-free data. The paper is titled Vision Zero, Scalable VLM Self-Improvement via Strategic Gamified Self-Play, and the implications for model training are quite significant. Beyond the headline, it alternates self-play with reinforcement learning using verifiable rewards, works across synthetic scenes, charts, and real photos, and reaches state-of-the-art results while slashing annotation cost. Also, the authors shared the official Python repository. Inside you'll find a README summarizing Vision Zero and its strategic self-play setup, plus a sample image. Code and trained models are marked as coming soon, with no releases yet. For now, it's a placeholder hub for the forthcoming implementation and usage examples. Alright, Figure 1 contrasts 3 training paths and motivates why the game approach matters. The left panel depicts supervised learning, which relies on humans to supply reasoning traces. The middle panel illustrates reinforcement learning that still needs handcrafted question and answer pairs, so costs remain high. The right panel introduces self-play, a setup where models compete against copies of themselves to create supervision from image pairs, which unlocks scalable improvement without manual labels. So Figure 2 shows how the approach changes accuracy across diverse tasks relative to the base QN 2.5 volts L7B. The orange and brown bars dominate, indicating consistent positive gains that beat state-of-the-art post-training methods using human labels. Gains are largest on reasoning and mathematics, with improvements approaching 9% in some cases. Chart and document and vision-centric benchmarks also rise, which signals good transfer rather than overfitting to any single domain. Alright, Figure 3 presents the overall framework and shows how the game and training loop fit together. The left panels illustrate the Who is the Spy gameplay with a clue stage and a decision stage, which pushes models to reason, deceive, and vote. The bottom left chart indicates that allowing any image input supports generalization across tasks. The right panels lay out iterative self-play optimization, where the clue stage uses zero-sum rewards, and the decision stage applies reinforcement learning with verifiable rewards so correct votes are reinforced. A small flow along the bottom depicts switching between these stages to prevent stagnation. With the training loop in mind, Table 1 shows that the game-based approach beats strong baselines across reasoning and math suites. The table aggregates several public benchmarks, which makes the comparison fair because every method runs under the same settings. The Vision Zero variants consistently top the QN 2.5 volts L7B base and most post-trained competitors, with the average ranking near the front. This matters because label-free self-play matches or surpasses costly annotation-heavy methods. Okay, 2 takeaways stand out. Strategic self-play over arbitrary image pairs yields real, cross-domain gains, and alternating self-play with verifiable reward reinforcement learning sustains progress instead of stalling. The broader implication is clear. Scalable, label-free training can outpace costly annotation pipelines while remaining stable in general. That is it for the AI Research Roundup. I am Alex. Thanks for listening.